live. Yeah, it is getting streamed now, but with a lot of dropped packets, which means that it is due to the internet instability in my room. Say for example, you can see that the drop frames is quite high over here, it is getting, and it is going live, but okay, with a lot of okay, so let's take a look at the curriculum, which means that it is due to the internet instability in my okay. So if we look at the syllabus, right, you will see that CS101 for computer science and electronics for 2020 onwards will be the same. So let's take a look at 2020 onwards. Yeah. So all of you students, kindly go through this syllabus right now. Okay. Okay, so you can see that it has a total of 5 units, okay, or 5 paragraphs is what it has been organized into, the entire course content. Okay, so the first one was Introduction to Computers, Number Systems and C Language. Introduction to Computers, Computer System, Computing Environment, Computer Languages, Creating and Running Programs, Software Development, Flowcharts, Number Systems, Binary, Octal, Decimal, Hexadecimal, Introduction to C Language, Background, C Programs, Identifiers, Data Types, Variables, Constants, Input Output Statements, Arithmetic Operators and Expressions, Evaluating Expressions, Precedence and Associativity of Operators and Type Conversions. We can understand that this has been completely covered, correct? And control statements, again let's go through it. Control statements, conditional control statements, bitwise operators, relational and logical operators, if else, switch statement and examples, loops control statements, for while, do while and examples, continue, break and go to statements, functions, function basics, user defined functions, standard functions, methods of parameter passing, recursion, recursive functions, storage classes, auto, register, static, extern, scope rules, type qualifiers. So these are also some things that we have covered. Then preprocessor arrays, yes, we have covered all of it, correct? Preprocessors and arrays, pointers and strings. I'm just skipping through. So we have covered all of that, and we have covered all of the structures, input, output, and all of these things as well. Okay, so last week I had told you that we have covered everything, but I looked at it again and I thought that we have not covered enum, and that is the reason why I shared that video lecture. Now going back, let me just a second. Okay, going back, let me see. Okay, so what I will do is, let me okay, you can actually choose any topic that you want me to revise. Okay, if you have any questions about any of the topics that we have covered, or if you want me to spend more time in any concept, or if you want me to write any program in any of these concepts, etc., you can tell me that and we will do it in this time. Students, am I audible?
Yes, sir, you are audible.
Okay, so Abhishek Kumar and anyone can say that. Okay, any topic that you want me to repeat, go through again, we can do that. Okay, since nobody is saying anything, What I will do is I will take my
So can you
Emacs.
discuss some questions using dynamic memory allocation, sir?
Yeah. So what do you want me to do?
Son,
Dynamic memory allocation.
son,
Some
and
questions.
structures also.
Structures and dynamic memory allocation. Is that what you want?
Yes,
Yes,
sir.
sir.
Okay. So what is the problem with dynamic memory allocation?
So there is
Who?
no much problem. Just I want like see some more questions on that, sir.
Okay, Abdul Akram is asking
Yes.
about dynamic memory allocation. He wants to see some more questions in that. Correct? Okay.
Yes,
Okay.
sir.
Okay.
And sir, also some advanced problem on structure also.
Also some advanced problem on structure. Okay. So have you been able to do the RC book problem with the structures that was there in one of the lab questions something?
Yes, sir. We
Okay.
have
Yes,
completed
sir.
it.
So now let's take a look at what is dynamic memory allocation. So dynamic memory allocation, as you all know, hello, am I still connected, students?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay,
Yes, sir.
because my computer got stuck for a moment. Okay, so dynamic memory allocation means that we are allocating the memory during the runtime of the program. Okay, meaning that we will allocate the memory when the program is running. Okay, and not at the time of writing the program. So which means that when you write the program, right, we will usually write int x, int I, etc. But when you do dynamic memory allocation, it is different. It is different in the sense when the okay, so whenever the program is running, that is when you call as runtime, meaning that before the program is running or before the program is loaded into the memory, it is just a binary executable. Okay, and once it is loaded into the memory and it starts running, right, that is when you call it as runtime. So runtime is when, say for example, right now you are seeing this Emacs over here, right? This is actually a runtime, meaning that it is actually running. So which, okay, so I have actually tried to open all the C files in the lab folder of your previous batch, and we can see that all the files are there. Okay, so this is the runtime of this particular Emacs text editor. Okay, this is the runtime of this particular Emacs text editor. So which means that whenever I want, right, I can create a new buffer. You can, it is asking me to switch to buffer. Default is Armstrong.c, or else I can create a new buffer. So let's say that I will create a new buffer. I just typed new buffer, but I think my computer is pretty slow. Yeah, so new buffer. Okay, so I can always create a new buffer, which means that it will allow me to it has given me a new space, okay, a new empty space in the Emacs text editor that will allow me to enter any text, enter any text, or create any program. Okay, so that is what I can do with this buffer. Now I can kill this buffer also. Okay, I can change whatever I want, etc. Now when you okay, let's take a look at dynamic memory allocation over here. I don't think I have any example for dynamic memory allocation over here in this one. Okay, so let's search on. Okay, let me open it. Okay, meaning okay, is this clear? So dynamic memory allocation means that allocating the memory for the variables or creating space for storing data when the program is running, correct? How do we access the memory area that is dynamically allotted? Can someone tell me? Students, am I audible?
Yes, sir.
Okay.
Sir, by using the point.
Yes. Okay. Because the variables are not named, we will use pointers, correct? Right.
Yes,
And after a particular memory area is used, okay, and is no longer required, what should be done? Students?
Free the space.
Yes, free the space. And why is it required to be done?
So that we can store new variables.
Yes, so that we can store new variables. Okay, if we do not free the space, those will be still assigned or allocated as memory area for our program. Okay, so if we do not free the space, then it will be still allocated, and when you want to assign more space, right, you won't be able to do it. Okay, now going back to some questions with dynamic memory allocations. Okay, so one was the linked list, remember that? So the linked
Yes,
list,
sir.
yeah, so the linked list was actually we learnt linked list with respect to two things. Say we learned it with respect to self referential structures. Okay, so that is where we said struct yeah, or the struct node, yeah, struct node, and then we had the struct node star ptr. Okay, or with this will be called as the next one, and this will be the int data. Okay, or if we say that this is going to be a student, okay, and this is going to be the roll number, okay, and let this be a character, okay, so that that has to be an array of, let's say, 20, then char email 50, okay, and so on. So which means that a node is something where you will store some data. Okay, a node is something where you will store some data, and a node is created with the idea that you will be able to add more data area and store more of nodes over there. Okay, so say for example, when we went ahead with the when we went ahead with the program, what we did was we had to assign new nodes, right? And that was done using malloc. Okay, so let us take a question, say, wow, okay, can you write a program that will read the content from the file, okay, assign memory to it? For example, say I'll write another, I'll write a problem statement here. So write a C program that will read n names from a file, their marks, okay, for various courses, prepare the rank list for every year as a report. So Abdul, Akram and Sunny, if I give such a question, do you think you can solve it using linked list? Or I'm sorry, not linked list, but using pointers and dynamic memory allocation? Students?
So there should be one for reading the file also.
No, I'm saying write a C program that will read n names from a file, their marks for various courses, prepare the rank list for every year as a report. Okay, so let's say okay, let's try to write this question a little bit more better way. So I'm saying that we have a database or a dump of so much data in a file. Okay, so we will have name, comma, roll number, okay, then we will have CS101 colon 97 comma CS102 98 comma PH101, okay, then 90, okay. Let's say you have such kind of details, and at the end you will have, let's say, 2021 22. Okay, so the name is, let's say, Ashwin, something like this. Okay, and then you will have multiple such entries. Let's assume that there are about let's say 10,000 entries or about 100,000 entries, okay, and you want to actually read that and then prepare a rank list for every year as a report. So you know that from this particular data that you will be reading, you have 2021-22 as the batch for that particular student, or which year did that exam happen. Okay, that information is there. So now you have to segregate. Say for example, there can be out of all the n students in the file, m students can be m less than n, m students will be in a particular 2021-22 batch. Okay, so that is where you have to prepare the rank list. Is this question clear, students?
Clear, sir.
Okay, now
Yes.
do you think that this is a good question for you to go ahead with dynamic memory allocation? Of course, you will be using dynamic memory allocation here, right? And you will have to read all the names, and then you will have to do something to generate a report. All right. Now another question that I can straight away think about is called say something called binary search tree. Okay, I'm going to tell you something called a binary search tree. Now a binary search tree, have you heard of trees like this? I mean, have you
Yes.
heard of trees and graphs?
Yes, sir.
Okay, so over here, right, I'm going to tell you something called a binary search tree. Now a binary search tree means that it's not a balanced tree or anything. Okay, it's not a balanced tree, it's an unbalanced tree, but all the elements to a particular node's left child will be less than that node, okay, and all elements to the right of the subtree will be greater than the node's key. So for example, the binary search tree, right, is a node based binary tree data structure which has following properties. The left subtree of a node contains only nodes with keys lesser than the node's key. Okay, so let's take a look at this particular tree. Okay, so this tree, right, that you see over here, you can see that 8 is the root, and from the left side of 8 you can see that there are multiple nodes, 3, 1, 6, 4 and 7, and you can notice that all the nodes have a value less than 8. Okay, and now another one is to the right we have 10, 14 and 13, and all the values that are towards the right are all greater than 8. Just a second guys, I am getting a call. Endada ഞാൻ നിൻ്റെ അടുത്ത് അത് പറഞ്ഞായിരുന്നോ? Okay. Right. So that is this is called a binary search tree. Okay. Now, when we are creating a binary search tree, there are advantages. Say for example, we have learned about the binary search. Do you remember about the binary search that we had in the curriculum?
Yes,
Yes,
sir.
Yes. So the binary search, right? You can easily compare at the root and check whether the value that you are looking for is greater than or less than this particular value. If it is less than, then you can always go to the left of the tree and keep searching, right? So this is also this can be created as a non-dynamic memory allocation problem as well. Or else if you have multiple data, if you have so much of data, that is when you will actually do it with the dynamic memory allocation. Say we will add one more thing here. If we have so many values to deal with, okay, that is when we will go with dynamic memory allocation. Okay, so this is binary search tree. I'll tell you something else now. Okay, this is called B tree. Now this is okay. Now you should take a look at this. Okay, what is written over here? And B tree is a specialized M-way tree that can be widely used for disk access. A B tree of order M can have at most M minus 1 keys and M children. Okay. One of the main reason of using B tree is its capability to store large number of keys in a single node and large key values by keeping the height of the tree relatively small. Okay, so you can see that a B tree, right? Not this one. Yeah, a B tree looks somewhat like this, which means that at every level, right, you will have multiple nodes and each node will have multiple keys. Okay, each node will have multiple keys, while in a binary search tree it has only left and right key, left and right children. Okay, so you have again more things, like for instance you can take a look at this thing: sorted linked list to balanced BST, sorted array to balanced BST. Okay, and then you have min heap, BST convert in place, convert BST into a min heap, and many other things. So you have to understand is that whatever concepts that we have learned, right, are concepts that you will be learning to use in the upcoming semesters as well. Say for example, these topics that I have just told you, just showed you right now, are from a topic called data structures, and you will also have these things when you learn algorithms as well. Okay, so this is binary search tree. Then you have B trees. Okay, so the B tree looks like this. Okay, so the idea with B trees and this binary search tree. Okay, now let's take a look at this binary search tree. Now what if I give you a question which says, let me write the question for you. Write a program to construct a binary search tree by reading n numbers from a file, or whatever it says, from a stream. Okay, now depending on the order in which the numbers are stored in the file, right, depending on the order in which the numbers are stored in the file, you will create a different tree always, meaning sometimes you have to add a new element to the right side of the node, or right side of the key, or of the node, okay, called a right child. Sometimes you have to do this on the, you have to enter on the left side, okay. So which means that whenever you are getting the values, right, numbers, you will either put it on the left side or you will put it on the right side. And again, depending on what is the value that you are going to read next, say let us say I am going to say 10, okay, let's take a look at 10, 12, 8, 9, 6, 15, okay. So if these are the values that you have, then just a second, let me create the draw also. The LibreOffice Draw software is actually loading, so it's taking a while. I'll just share the link for today's video, okay. Yeah, no, the LibreOffice Draw has still not loaded. Just give me some time. Can someone tell me what is the error in this picture? Why is the right one incorrect and why is the left one correct? Because the rule is that,
So the left node should be
Two
less
is
than
less than
the
three.
above node.
yeah, the number 2 over here, right, is actually less than 6, but it is greater than 3. So since it is greater than 3, it has to, I mean sorry, I'm sorry, 2 is less than 3, okay, but whatever numbers that has to appear on the right side of the 3, right, should all be greater than 3, but 2 is not, and hence 2 should be on the left side of 3. So it should be 3, 1 and 2 here, okay, not 6. So let me see if the draw has, no, the draw has not opened yet, my goodness. Okay, so anyway, let me go back. So this this ordering of the numbers, and if I give 10, and this ordering of the numbers, right, would give you two different binary search trees. Okay, these would give you two different binary search trees. I am saying BST, binary search tree. Okay, so that is the reason why we will have to use dynamic memory allocation. Okay, so even if it is to read all the RC book details of a particular RTO into a program, okay, we will have to use dynamic memory allocation, right? We can do it that way. Okay, we can actually do it using the dynamic memory allocation. So which means that you can use structure here, and let's say structure, struct and dynamic memory allocation. Okay, so there was this one particular question, let me show you that. There was one particular question in your CS101 CT2. Let that open. No, unfortunately, my LibreOffice Draw is crashing. Okay, I'm able to see it on another screen, so I have two computer screens connected. Okay, it has loaded now. Yeah, so let us take a look at both the trees that we want to do. So 10, 12, 8, 9, 6, 15, right? So the numbers are, it's very slow, unfortunately. Okay, 10, 12, 8, 9, 6 and 15. Okay, so here we will put 10 here, correct, and the next element that we will get is 12, which we will put here on the right side of 10. Okay, and then what we will do is, okay, so this will be like this. Okay, and then 8 is the next element that we get. So 8 has to be now put here, okay, because 8 is less than 10, so it will be like that. And then the next element that you get is 9, so 9 will be put here. Okay, okay, and then the next element that you will get is 6. Okay, and when you look 10, 8, 12 and 9, so 6 has to be placed on the left side of 8. Okay, so 6 will be placed here. Okay, and then 15. So 15 will be placed where? Can someone tell me? To the right of 12. Okay, so which means that there will not be anything that this will be pointing to. This will always be pointing to null. and the children of left and right children of 9 will also be null, and the left and right children of 6 will also be null, and the left and right children of 15 will also be null, but for the left child of 12 will be null. So that is one number. And then if we have 12, 10, 9, 6, 8, okay, let me write the next one. 12, 10, 9, 6, 8 and 15, correct? 12, 10, 9, 6, 8 and 15. If we have that, then the binary search tree that we will create would be, say, 12, okay. Then towards the left of 12 we will have 10, okay, and towards the left of 10 we will have 9, correct, and towards the left of 9 we will have 6, right, 6, and towards the right of 9 we will have towards the left of 9 itself we will have 8, but 8 is greater than 6, so 8 has to go here, which means 8 will come here, and then next is 15, and 15 will be here. Okay, now let us try to put the arrows, right? So it will be like this. So this is something called binary search tree. Okay, that this is you should understand that this is a tree structure, but only constraint being that for every node, right, all the elements on the left will be less than its value, and all elements on the right will be greater than its value. So that is what has happened here, correct? So we have created two binary search trees. For the numbers 10, 12, 8, 9, 6 and 15, and another one for 10, 12, 10, 9, 6, 8 and 15. Okay. So this can be a problem that you can solve with dynamic memory allocation. Okay. But let me also show you something, because I have told you this. Okay, there is something called AVL and red black tree as well, which are balanced binary trees. Okay, so these are called balanced binary trees, and the reason why it is called balanced binary tree is that you can see that there are only 3 levels here, but over here, right, 1, 2, 3, 4, 5 levels are there. Okay, for the two binary search trees with the same numbers, okay, but in different order, we have 2 different binary search trees, and these can all cause some issues with respect to the time taken to compute the solution. What did I say? The time taken to compute the solution. What did I say again? It can be a search operation, it can be an insertion operation, it can be a deletion operation, it can be a simple search operation. So for example, I want to see whether in this list number 8 is there or not. For finding out whether 8 is there or not, right, I will have to do multiple comparisons, 1, 2, 3, 4, correct, 4, and the 5th comparison I will get 8. Over here, right, I have to do only 2 comparisons, 1 and 2. Do you understand what I am trying to tell you? So this is something called a binary search tree. I am not teaching you binary search tree. I'm just explaining this concept because this is a very good concept that you can actually ponder about when you want to look into the dynamic memory allocation. Okay, so here, right, so which means that we have clearly seen that with respect to how we store the values and, right, how we store the values, where we store the values, there is a huge difference in the number of steps that we will take to find out whether that value is there in the list or not, correct? The number of steps will vary from 2 to 5 here. So just imagine if we have 1 lakh numbers. Of course the number will be different, right? The total number of calculations or the number of comparison that you need to do, computations that you need to do will be different. Okay, so this is what you call as
Sorry to interrupt you, sir, but
yeah, you have another class, right?
yes, sir.
Right. So this is a binary search tree, and the reason why I told you about binary red black tree and AVL tree is because those are called balanced trees. Okay, a red black tree is a self balanced binary search. Okay, so don't worry about learning this at present, but I'm telling you there are topics that you will definitely learn in the upcoming semesters which will require you to do dynamic memory allocation. And for this one also you can try creating a simple binary search tree. Okay, so create a simple binary search tree using dynamic memory allocation. Sorry students, I took some more time because in between I lost the internet connection. So that's it. And with respect to structures and dynamic memory allocation, I will give you more questions. But in the meantime, if you can send me the list of the topics that you want me to go through, right? That would be actually very good. So maybe through the class representatives, through Ravish and I think his name is Yadav, right? You can actually send me the list of the topics that you want me to cover. Okay, so that's it guys, let us meet in the next class tomorrow. Okay, we will go through the topics. Bye, see you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.